Okay, in this example, we're going to be solving the radical equation, the square root of x plus 8, and then outside our radical minus 3 equal to 2. Anytime you solve radical equations, you want to be careful because sometimes the algebraic process will introduce what's called extraneous solutions, which are solutions that work out algebraically but doesn't actually solve the original problem. So as we go through solving this equation, we're going to use a very simple strategy. Since x only occurs one time, we're just going to use reverse order of operations. So I can't touch anything underneath the radical until I get rid of everything outside, which means the subtraction and the radical itself. Radicals are at the same level as exponents, so we'll get rid of the addition and subtraction outside first. And we'll do that just by adding 3 to both sides. That will give us the square root of x plus 8 is equal to 5. Now, to get rid of the radical, the opposite of square rooting something is to square both sides. So I'll square both sides here. Squaring a square root, those are opposites, and will cancel out, leaving me with x plus 8 equals 25. Then we'll finish it off by just solving what we have. So we'll subtract 8 from both sides and get x is equal to 17. Now again, remember, sometimes extraneous solutions will form, so we should double check our solutions. So the square root of x plus 8 minus 3 equals 2. Double checking this, our x is 17. 17 plus 8 is 25. The square root of 25 is 5. And 25 minus 3 is indeed 2. So yes, 2 is our solution. Okay, in this example, we're going to be solving the equation, the square root of the difference of x and 8, equal to 3 times the square root of x. Now, as we solve this equation, the typical strategy works if x only occurs one time, but you can see that we have x here multiple times. So the typical strategy of just doing reversal order of operations won't work. So there's several different approaches we can take depending on the situation as to which one's most efficient. For this one, since there is no addition and subtraction outside the radicals, and there's one radical already on each side, the easiest approach is just to take to square both sides of the equation. Usually, if x occurs more than once, that is usually the best way to go. So we'll square both sides of the equation. On the left side, squaring a square root will cancel out, leaving us with x minus 8 equals on the right side. Because there is something else outside the radical, we have to take that into account. Luckily, though, it's connected by multiplication, so we can apply exponent properties, which just says if we are squaring a product, then we just square each individual factor. So squaring 3 gives us 9, and then squaring x squared just gives us x, because the squaring and square rooting cancels out. Now that we've gotten rid of the radicals, we just have to determine what type of equation this is. Sometimes they do come out to be quadratic, so you have to pay attention to this. But since there are no exponents here, this is linear, and we'll move x's to one side, and then just solve it like a normal linear equation. So we're going to have negative 8 equals 8x, and divide both sides by 8. In doing so, we have negative 1 is equal to x. Now we do have to be sure to check for extraneous solutions, because sometimes this won't actually work. And in this case, whenever I go to double check this equation, we'll have x minus 8 equals 3 square roots of x fill in my x, which is -1. Well, remember, since we're dealing with real solutions here, we cannot have negative numbers underneath a radical. That creates imaginary numbers, which means there's no actual solution or real solution to this equation. -1 doesn't actually solve the original equation because we can't have the negatives underneath the radical, so therefore there is no solution. Okay, in this example, we're going to be solving the equation, the square root of the sum of x and 2, then outside our radical plus 10 equal to 1. Since x only occurs one time, we can do this one with reverse order of operations, getting rid of the stuff outside the radical first, subtracting 10 from both sides. Give me the square root of x plus 2 equals -9. And then, to get rid of the squaring, the square rooting, we'll square both sides, giving us squaring and square rooting cancel, letting me have x plus 2 equals -9 squared, which is positive 81, and subtract 2 on both sides, giving us x equals 79. Now, if we try this in our equation, try to check it, the square root of our x plus 2 plus 10, is that equal to 1? As we try to check it, plugging in our 79, 79 plus 2 is 81, and the square root of 81 is 9, plus 10, is that equal to 1? No, it isn't. That's not a true statement, so no solution. Oftentimes, you can tell with the radical ones, especially if x only occurs one time, if you have the square root of it equal to a negative number, that's a good indicator that you won't have a solution. Keep in mind, if it's an even root equal to negative, an odd root equal to negative is perfectly fine. Okay, in this example, we have a cube root of x plus 4, and then outside my radical, I have plus 8 equals to 5. So this one is slightly different because it's a cube root. However, the idea or process behind it is going to be exactly the same. Since x only occurs one time, we'll get rid of anything outside the radical first, then get rid of the radical, then get rid of whatever's left. So we will start off by subtracting 8 from both sides. Give me the cube root of x plus 4 equals -3. Then to get rid of the cube root, we shall cube both sides. Cubing and cube rooting cancel out, they're opposites, leaving me with x plus 4 equals the -3 cubed is going to be -27. And then one more step to get x by itself. We will subtract 4 from both sides, which will give me x equals -31. Remember to double check our answers here. So the cube root of our x plus 4, then plus 8 on the outside, is that equal to 5? Our x value this time is -31. To double check, -31 plus 4 is -27. Oops, I forgot my index. The cube root of -27 is -3. You can do a cube root of a negative, not a square root though. And -3 plus our 8 is indeed 5. So -31 is indeed our answer.